Hi, this is Eric from Cartesi, and today I'll have a conversation with Felipe Argento. Felipe Argento is a software engineer and blockchain expert who has given a lot of contribution to Cartesi. In fact, Felipe was the very first engineer to join Cartesi's team. Felipe has given lots of key contributions to the project, including what we can call the very first ever implementation of a RISC-V emulator on Ethereum, which is quite cool. Now, Felipe is working on another fundamental feature of Cartesi, which is optimistic rollups. Felipe, welcome. I would like to start this conversation asking you how your involvement with software begins.
Well, I guess as many in my generation, it started with games. So I play a lot of games, online games when I was a kid. And then you try to cheat and try to hack other people, and you try to not get hacked. And then you end up learning how to mess with this stuff, and you end up falling in love. But very soon I realized that I didn't really want to work in games. But then I was old enough to start seeing the value in technology and how it can affect people's lives, and how like the cool techs were impacting everything. So I just fell in love, and then I went with it.
Exactly when do you start to shift from focusing on games to focusing on, let's say, real life problems?
Well, I guess like high school, end of high school and beginning of college, I was already sure that I didn't want to do games. And then I was trying to decide what to do. And I was going towards AI, playing around with like some genetic algorithms and neural networks. Actually, my final project in college was about AI. But then I found out about blockchain, and it was instant love.
Nice.
Yeah.
By the way, we came from the same school in Rio de Janeiro, which is a Catholic university, PUC. And I'd like you to tell a little bit about your experience there and also your involvement in Tech Graph. How was it for you?
Yeah, sure. PUC is a great college, university, I guess. So many smart people, not only the professors who are brilliant, some of them are like recognized internationally, but also the students are also very good. So I have a lot of good memories, a lot of good friends from PUC. And Tech Graph was a life-changing experience, I guess, because I started my internship there very early. I guess it was my second year of college, beginning of the second year or the end of the second year. So I didn't know anything basically, right? I went to college and I was learning, I guess, calculus and physics, and I knew nothing about computing or computer science. So it was awesome. I just joined in. The guys took me under their wings, and I learned a lot. A lot of cool people working there, a lot of PhDs and smart people. So it was a very nice beginning for my career.
Yeah, I also have great memories about my time in Tech Graph. I think I started working there on the second year of my university involvement. And what I found quite cool about Tech Graph is that it was a company inside of the campus, but there were lots of academics, lots of researchers, and there was something really alive in the atmosphere in there. Yeah. It was actually, I went to university much earlier than you, right? It was 96 when I started work at Tech Graph. At that time, we were developing very primitive computer graphics solutions. I don't know if you remember the library called CD, Canvas Draw. At that time, Lua was also being developed. Probably don't remember, it's quite old.
Yeah.
And I was developing 2D graphics primitives and drivers for printers and things like this, which was quite cool for me in my early career as a developer. And it was also a place where I was working together with other people that work with us today at Cartesi, like Milton and Diego, of course.
Yeah, I also
had lots of great experiences in Tech Graph. For instance, we used to play at that time a very nice 3D first-person shooters like, what was the name? It was called Duke Nukem that
Oh
came.
yeah, that's a.
Well, yeah,
I don't
was
think I've
quite
ever
cool,
played it.
and we were so addicted. We were playing in the network of TechGraph. There were lots of people on both floors playing throughout the nights. And I remember that one day we played so much that we lost track of time and we were locked from the outside. So we had to sleep inside of TechGraph. That was really, really fun. So I had to spend, we
That's
were
awesome.
obliged to spend the whole night playing Duke Nukem until the morning for someone to rescue us. So yeah, I have good memories of TechGraph. It was quite cool.
Yeah, one of the cool things about working in TechGraph is that I was just beginning college, but I was already working on projects that were like for outside companies. So I remember that I built this panel that showed trucks for like Petrobras, which is one of the biggest Brazilian companies.
Yeah.
So I was just a kid and I was already making
Yeah.
something that I guess mattered. So that was quite cool. Yeah.
Interesting. I was also involved with a project from Petrobras, which is the Brazilian oil agency, and
Yeah.
it was the early days of GIS, Geographical Information Systems, and we were doing the first things with maps and big databases, and that was really, really nice for me as an early student of computer science to be working in such important projects, as you say. So let's fast forward in time and try to spot the moment that you fall in love with blockchain. How does that happen?
And that's a good question. I don't quite remember it. I remember reading about blockchain and Bitcoin on Reddit a long time ago. I even remember talking to my family about it. But at the time, everything you try to read of like more legit sources, they were all very skeptic about blockchain. And I also started dating at the time, so you know how things are. So I kind of left that aside for a bit. I was always following things, but never actually diving head first. But then eventually, I actually took a class at Book with a finance professor, a course about cryptocurrency. Sorry, and it was quite interesting. And actually, when I signed up for the course, before I even started it, I was already in love because I signed up and I was like, oh yeah, I remember this. Let me check it out. And then I had a more mature view, I guess, because I was a bit older. And then I was reading online. I was, I guess, smart enough to make my own opinion, to have my own opinions already. So I found out about Ethereum, for instance, and instantly fell in love with all the possibilities. And then I guess I showed up at the class and I already knew a lot. And after that, it was like game over.
Yeah.
That's all I could think about. Yeah.
Yeah. Are you able to spot exactly what property of blockchains or features probably related to possible impacts on society, on economy, on the macro level that inspire you, or something more technical?
No, I think, well, the technical part is definitely like very interesting. But I think what caught my attention the most was the ability to remove value from intermediaries. So this weird notion that you have an entity that takes care of trust between parties and charges a lot of money for that, but actually doesn't actually add a lot of value to the transaction itself. And I guess the money part was also quite interesting, even though I'm not very knowledgeable into monetary theory. But I guess being from South America, right, you don't trust a lot money governed by our states or governments. We see our neighbors, we see big crypto communities in Argentina and Venezuela, and also in Brazil. So I guess this trust of centralizers and big authorities, that distrust led the way and made me fall in love for it.
Yeah. There are at least these two assets, right? The inefficiency of centralized intermediaries, but also the eventual malicious misuse of power of centralized institutions, governments, and
Exactly.
big companies, for instance. So of course, the blockchain can help a lot with that. And then at some point, you decide to found a company right?
Yeah.
Which was called GoBlock. Can you
Yes.
tell us a little bit about it?
Sure. So when I started getting interested in this world, I started to put a little bit of money in it, right? I was a college student. I didn't have much money at the time, but not that I have a lot of money now, but I had even less at the time. And then I was getting together a friend and my brother to invest in cryptocurrencies. And we decided to start this research group. So the idea was that we would look into, at the time, it's like the ICO boom, a little bit before that. We started looking into the coins and researching with the idea of putting money in it. But then we realized that this technology was awesome, and it would be much more interesting that instead of putting money in it, we could put time and effort and knowledge. So we decided to actually form a company and start developing our own products, our own ICOs, I guess, or things like that. We started like got very involved in research very quickly. So we had a partnership of sorts with the university. So we're doing like helping big companies understand how they can use blockchain. So we had some very cool projects with renewable energy and carbon credits and things like that. So it was quite awesome. So it went very quickly from the idea of just investing money into the idea of actually building something and leveraging this technology.
Yeah, very nice. You guys were pioneers in Brazil for sure.
Yeah.
Then one day, someone from Cartesi calls you. That was
Yeah.
me, right? It happens that Milton was a common colleague, and Milton introduced me to you, and we had a conversation over the phone. I explained our ideas at that time. Of course, ideas changed quite a bit since then.
Yeah.
But I remember that on the phone call, I didn't feel you were particularly excited about what we're doing. But then sometime after that call, you call me back, and for my surprise, you were interested in joining our project.
Yeah.
How was it?
Yeah, that was a funny one. I guess it was a very unexpected call. And I had my own company, right? And we were doing some nice things. I really enjoyed working there. So I was not open to any opportunities, basically. I would have said no, basically to anything. But then you called me and you had a conversation, and I entered the conversation with the thought of saying no already. But then after the talk, something just kept bugging my head. And I realized that what Cartesi was building was beautiful. Even at the time, now it's like much more advanced and much more mature and much more beautiful even. But I realized that Cartesi was a sort of a Go block with more mature people. So instead of Go block, which was founded by people just out of college, even in college, still some of us, I guess Cartesi had a beautiful vision and also had the infrastructure to support that vision. And then I had to join in, right? And we had the professors from INPA, which is I guess internationally famous mathematics institute, which in Brazil is very, very famous. Everyone that goes there is known as a genius. You had a lot of experience and you had the opportunity to move abroad. So I had to go.
Yeah, I can actually relate to what you're saying because the first time Diego called me and told me about the project. So Diego is one of the founders that is also an academic, and he's a math professor at the Institute of Pure and Applied Math in Rio de Janeiro, INPA. And he called me. He was developing the idea with Augusto, his colleague at INPA. And he told me the project, and I was not very excited, but something kept bugging inside of my head until one day that I had to just surrender to their idea and join the project. So yeah. I think we had a kind of a similar story there.
Yeah, I guess if a good rule of thumb is that if smarter people than you are very excited and you're not, maybe you should stop and think about it a little bit more.
That's a good point. Yeah, for
maybe
sure.
There's something you're missing. Yeah.
Right. So let's get a little bit more into your work. maybe you can tell us a little bit about briefly what you did in the past and how you transition into your next exciting implementation of rollups.
Sure. When you say my past, you mean inside Cartesi, right?
Inside Cartesi, yes.
Yeah. So I started, the first thing I did when I joined in was to take a look at the arbitration part of the code. So the arbitration part is the code that governs the verification game and the interactive protocol. I'm not sure how much our viewers are already know, how much they know about Cartesi already, but the whole protocol of enforcing people's honesty, that's the arbitration part, and that's what I started with. Mainly writing the tests, because the prototype of the arbitration was already done by Augusto, so I started with that. And then I got the big challenge of writing a RISC-V machine on Solidity, which was quite challenging. A lot of limitations and a lot of challenges, I guess. The good thing is that the code written in C++ by Diego was beautiful. So it was very well documented. It's a art piece, I guess. It's a beautiful piece of code. So I had a good reference to follow.
Yeah, I would actually like to stop there for a while and allow you some time to explain to people why we even needed to have an implementation of instructions of a RISC-V architecture on the blockchain.
Yeah, that's a good point to bring up. So the idea of Cartesi, like very simplistically, is that we're gonna run things off-chain, right? So we have this very powerful machine that can run a real OS with all the tools, all the advantages that a real OS like Linux gives you, and you run that off-chain. So you're not bound by the limitations of the blockchain. However, if you want to do something that is permissionless, decentralized, which is the whole point of this industry, then you still need the base layer of the blockchain to make sure that everyone agrees with the end result, right? So what happens is that on Cartesi, you run all these computations on this beautiful machine that was written by Diego, and it's deterministic. So if you agree on how the game works, we are sure that the game, unless one of us is cheating, we are sure that the game is going to work as predicted, right? So if everything is good, no one's cheating, you can run it all off-chain on this beautiful machine that Diego wrote. However, there's no intermediary. We don't have a Supreme Court to decide if someone's cheating, right? So if something goes wrong in that game, then you have to solve that somehow. Since it's only 2 players involved in the game, there's no third party to actually mediate the dispute for them. But then there's the catch, because since this machine is deterministic and they agreed with the results of the game beforehand, they can take the dispute and put it on the blockchain. So the blockchain holds reverse implementation of this emulator, meaning that everything the emulator can run, the Solidity machine, the machine inside the EVM, can also run. Of course, in orders of magnitude, like more expensive and slower. But so the idea is that you find out off-chain which exact instruction in that game you guys disagreed on. Exactly the point when the first cheating happened, and then you run that part on chain, on the blockchain. And that's why you need the reference implementation, because you're choosing a little part of the whole thing that the machine ran, and you put that on the blockchain, and the blockchain runs it on the code I wrote, or the Solidity code that we were talking about. And the Solidity code is capable of deciding who was correct, or like who messed with the machine's implementation. So yeah.
Yeah, that's quite cool. I like to think of it also as we are providing the ability for Ethereum or other blockchains supporting smart contracts to emulate RISC-V architecture and run arbitrary computations and OSs on top of it. but we are doing all the heavy lifting of the computation itself outside, and only using the blockchain as a referee in case there are some problems and disputes happening among the people that are involved in this computation outside. But it's just like we had a microprocessor on top of the blockchain in a certain way, right?
Yeah, yeah, that's when it's like the combination of the two advantages, right? On one hand, we are providing this awesome tool chain, this ability to use whatever libraries you want, even like the zero knowledge libraries. You don't have to port them to Solidity. You can use whatever you want. And you can also run much more intensive computations. So you can run billions of instructions and summarize that on the blockchain very easily. So
yes.
I think something big.
So all of this work ends, let's say, this first stage of implementation of Cartesi ends with the release of the CART SDK version 1.0 that we did a few months ago, which we call the computational oracle, right? So the blockchain specifies some heavy computation to be performed off-chain on the Cartesi machines, and the results are placed back on chain in a secure and verifiable way. Now we want to go one step further. We actually want developers to eventually forget about using Solidity and developing their smart contracts directly on a real operating system. So that would mean that not only current Ethereum developers, they could have more tools to develop the apps, but actually we would open the doors to developers, mainstream developers, to code with their preferred tools, the tools they use on their daily lives, and they wouldn't have to learn Solidity or anything specific to blockchains. They could just go to Cartesi and develop their smart contracts directly on the second layer. So that's why you are working now on the rollups. Would you like to expand a bit on this idea of rollups and what is behind this?
Sure, yeah. I think the rollups is a entirely different ballgame. Of course, you're going to leverage the beautiful work we did on the cards 1.0 because the computation oracle is also necessary for the rollups. But the rollups allows us a level of interaction with the machine that was not possible with the first cards. So as you said on the first version, you just specify a computation and you can run it, you can dispute it, but you have to keep interacting with the blockchain for every computation. And there's a long period of time, and the machine is stateless, so it doesn't hold state. With the rollups, what we want to do is to actually create something more similar to a real computer. So you can have different input drives, and you can run different commands on the machine, and you can actually advance its state much faster than you would normally. And that gives you the possibility of creating very impressive things while retaining the securities of the blockchain and the decentralization. We have increased the throughput and latency by a lot. So it's quite interesting. I'm very excited about it. It's also a field that has been gaining a lot of attention. Even Vitalik recently wrote about the necessity of layer 2 solutions, specifically rollups, both optimistic and ZK rollups, which are very interesting in their own rights. And yeah, I'm very excited. You've been writing a very cool article about the rollups also, right? So if you want to share something.
Let's see how it comes in the end. Very recently, a few months ago, we had a congestion problem on the Ethereum network. With the explosion of DeFi, lots of people started to use crazily the Ethereum network, and the transaction fees went to the sky, right? So very, very fast, the blockchain became kind of gentrified, and lots of applications, they were not possible to be used because the fees were just very high. And only people that were either rich or they were really playing DeFi seriously were able to use the network. And at that time, I remember that Vitalik and the Ethereum Foundation, they were really speaking about the importance and the urgency of having rollups deployed, so
Yeah.
so that Ethereum could actually move throughout the next years in a way that's scalable and would provide sustainability for the network and for the apps on top of it. So it seems to me that Rollups is really the word of the day, and is fundamental. And there are other companies and groups, very smart people, also working on Rollups. And in your opinion, what do you think is interesting about our approach to Rollups?
Well, first of all, we keep mentioning here the Linux, right? The fact that you're offering a rollups, but not with the EVM or not with the like stuck to Solidity, but you are offering a optimistic rollup with this entire toolchain and this universe of possibility of decades of software stacks, right? Decades old software stacks, and I think that's a massive advantage. I really like the simplicity of our design. So it's coming up, it's looking very nice. Yeah, and then the level of the intensity of the computations that we are able to perform is very nice also. And I think it's going to come together with, like, of course, a lot of people are trying to solve this problem of the blockchain being not very scalable. So we have Ether 2 now that's coming along greatly. Very excited, great progress there. There's the EIP 1559 that deals with this gas problem, which is also a major issue. And that combined with rollups, optimistic rollups or ZK rollups, that has the potential to actually bring blockchain to what it's supposed to be, right? Because we can talk a lot about the world computer and decentralizing everything, decentralizing the web. But as long as, well, we have to fix these problems first, right? Because if the network goes down because of a few DeFi products or a few popular contracts, then, well, the vision is not going to become a reality.
True.
So I'm really excited to be working on something that, well, will allow both the scalability in the terms of intensity of computation, but also give the developers power to develop more interesting applications. So even we can think of massive multiplayer games. That's something we talk a lot inside the Cartesi. That would be awesome to have. We can think of complex finance instruments and things like that. So.
Mm-hmm. And how do you see the future of blockchain technology and decentralization as a whole? I know it's a hard question. It's very hard to predict the future, right? I think at the beginning of the internet, it was not easy to foresee Airbnbs, Ubers, and social media like we see today, right? But of course, the internet allowed for an explosion of new business models, new ways for people to interact. They provoked even deep changes in the psychology of human beings and in society itself. And right now we are seeing so many changes in the fabric of society that it's even hard for us to catch up. So there's a lot of discussion about all the implications of internet and social media in our lives nowadays. And I think that blockchain is going to be massive as well, because when you create an internet of value and you create digital scarcity and verifiable computation, that opens the doors for many other angels and demons to come out of the Pandora box. So would you dare to sketch some possibilities for the future?
Yeah, sure, I guess. Can always try. Oh, I think it's frozen. Oh, am I back? Okay, I think I'm back.
You're back.
Sorry, it froze for a bit. So I think it's very interesting right now, because if you look at the blockchain world, both Bitcoin and Ethereum and all the other chains, most of the applications are trying to rebuild something that already exists, right? So it started with Bitcoin, which is trying to reinvent money. Well, money has been around for a long time. And now with Ethereum, we have a lot of different applications, but most of them are trying to repeat things that exist in the real world. So lending and bonds, loans, options. So these these finance instruments that are already possible in the normal infrastructure, but maybe they work better with the blockchain. What I'm really interested in is things that are going to be created that were not possible before blockchain. So I think that's when things are going to get, well, a bit crazy, both for good and for bad. But things like liquid democracy or like delegated democracy, that's a beautiful concept that blockchain seems to be part of the solution. Things like, I'm very excited about automated prediction markets and betting markets. I think that's gonna radically change, well, I guess everything, because it's gonna create a huge incentive for people to put their information out there. So the classic example is when you buy a product, you bet a little bit on the revenue of that company. So you're incorporating your privileged information to that company's revenue, right? So you make money automatically because you're adding information that no one else has. But at the same time, you're increasing the predictability of the entire system. And if you have a predictable society, then it's much easier to deal with a lot of problems. So I think that's, so delegated democracy is a big one. I think automated prediction, what else? There's the classic combination of AI, IoTs, and blockchains. So we have a self-ownership of devices, so sensors that sell their data, and they work for themselves, or cars that, Ubers that own themselves. I think that's gonna be like insane. And well, the good news is that all the technologies are advancing well, and the combination of them is, I'd say, is inevitable. And also the good news for Cartesi is that it's hard to see a world in which blockchains are connected to so many different things. And in the same world that blockchain has to have a operational system, right? Operating system, in order to be able to deliver on all those promises. So
yeah, we have been working on top of this premise, right? At the beginning of Ethereum, there was this promise of having a world computer. I think that's a very interesting quest for the world computer, but of course, we're still far away from that because the computer performs really badly, and this computer doesn't have an operating system. So I believe that we're building something that gets us closer to that vision. Right? So Ethereum has been around for quite a while. There are other blockchains that support smart contract coming up as well. And there are so much experimentation around governance, about economy, about cryptography. So many areas are experimenting so many things that I'm very excited to see what's going to happen in the future, especially when the technology becomes much more robust and mature and efficient. Then I think we're going to see a very interesting explosion of creativity and some profound changes around us. So I think we're getting to the end here. I'd just like to ask you to give maybe some final words of incentive to our colleagues in tech. What would you say to people that are, let's say, working with software but are not too much aware of blockchain yet?
Sure, yeah. Just to expand a little bit on your point, I think it's not only beautiful what's coming, but it's also inevitable. And I'm not sure about insights, but well, yesterday, I guess, Google went down, right? All Google services went down. And I was on my phone, I was checking Google Maps, and it was not working. And I thought I had forgotten to pay my phone bill because the internet was not working, right? Because Google was not working. So I think there's a chance that we're relying too much on too few, so we're relying too much on Google, we're relying too much on Facebook and all these big companies. So let's decentralize things and let's build new things and let's believe that things can be done in a different way, a more inclusive way, that you can offer these services to less fortunate people. You can, as people like to say, bank the unbanked, and offer them financial services and offer them ownership of their own data and their own lives. So yeah, I'm not sure about an insight to developers and technologists, but just let's be brave and build new things, I guess.
Good, beautifully said. I think that's encouraging. And I think that's a good tone for us to end our conversation. Thanks a lot, Felipe, and let's keep implementing rollups.
Thanks.
Bye-bye.